This video is about a doubt or belief that has been there in my mind for quite some time now. In this video, this is expressed in terms of an experiment, and any help in clarifying this or even sharing this view is highly appreciated. And let me thank you for this in advance. This experiment is based on these four well-established facts that
1. Current is the rate of flow of charge. Any charge, not just the flow of electrons. Not talking about displacement current here since it is irrelevant here. 2. There is a magnetic field around this flow of charge. 3. Classical physics is purely deterministic. Therefore, definite causes should have definite results. 4. Observers in the same frame of reference, who are at the same point, and stationary to each other, should agree with same or similar incidents.
Before coming to the experiment, the reasons for this experiment are explained. Otherwise its necessity would not be appreciated. Moreover, it greatly helps in expressing the viewpoint a lot so that you can answer correctly to the point. Consider the setup as shown in the diagram. A wire is connected to the two terminals of a cell to make a closed circuit. And let I be the current flowing through it. AB is a very long straight portion of the current-carrying wire. Let Q be a test charge position near to the conductor AB. Now, depending on the relative velocity between AB and Q, we can have these two cases. Case 1. The conductor AB is at rest with respect to Q. Here, Q is in a magnetic field due to the current. But there won't be any magnetic force acting on it. Case 2. The conductor AB is moving with a negative drift velocity. Here, there is a non-zero magnetic force acting on Q. Now if we replace Q with a metal strip CD, then the magnetic force acting on the free conducting electrons in CD causes a potential to be developed across CD. No such potential is developed in case 1. Rearranging case 1 and case 2, for visual symmetry and reasoning. We have a situation like this. There is no force or potential in case 1. Whereas in case 2, there is a force on Q, and there is a non-zero potential across CD. Here, it can be seen that, in both cases the test charge Q, or CD, is under exactly similar conditions. It is stationary with respect to one kind of charge in AB, while it is moving with respect to the other, opposite kind of charge.
Here, apart from the sign of the concerned charges, nothing else should matter here.
However, the results are different. Concerning Q. In case 1 there is no force acting on it. But in case 2, there is a magnetic force on Q. And similarly, with regarding to the effects on the metal strip CD. In the former, there isn't any potential developed across it. Whereas in the latter case, there is a potential developed across CD. If one is to believe that definite causes should have definite results and that we cannot have different laws of physics for a particular phenomenon in the same inertial reference frame, then it can be seen that case 1 and 2 are indeed similar. And therefore, since there is a force, F equal BQV, which acts on Q in case 2, a similar force should act on Q in case 1 also. Similarly, since there is a potential in case 2, there has to be a potential in case 1. So, if there is a potential developed in case 1, then why can't we measure that? The possible reasons for that are, 1. The parts of the probes that are equidistant from the wire AB are at equipotential. Therefore, the multimeter always reads 0, and it fails to detect this potential. Additionally, the potential developed across CD is of the order of a few picovolts. Clubbed with the above reason, it makes it almost impossible to be detected. So, believing that classical physics is deterministic, and that this could be the possible reason for the detection of zero potential across CD, one can straightforwardly calculate the force on Q in case 1 to be as shown. It should be noted that, 1. At the macroscopic level, this still retains the equation for the net force as F equals BQV, which is independent of the relative velocity of the moving charges.
This too can explain the force between two parallel current-carrying conductors, explain the properties of magnetic north and south poles, and the reason why they behave so, and so on.
And 2. The force between charges in motion is not always related to the square of their relative velocities, about which is mentioned in the later part of this video.
What was said above can be easily proved with the help of the following experiment. This experiment is based on the above equation, that this force on the electron is proportional to square of the relative velocity and sign of the concerned charges. So materials with different drift velocity, or with different current carriers, should exert different force on charges placed near to them.
Consider a straight long tube CD, which on conduction, electrodeposition of copper takes place at the cathode. The cathode is in contact with a long piece of metallic wire AB, which is connected to the negative terminal, and the anode is connected to the positive terminal of the battery, forming a closed circuit. PQRS is a piece of wire or a metal plate, shaped as shown, and is placed near this ABCD arrangement. In the tube, the carriers of current are the positive ions, whereas in the wire, it is the electrons that conduct electricity. On conduction, as per the equation, the conducting electrons in AB repel electrons in PQ away from it, whereas the moving cations on the tube attract electrons towards it. This causes a potential to be developed across PS, and can be measured directly. So the question is, would there be a potential developed across PS? Now, the force between two charges in motion is not always related to the square of their relative velocities. For example, consider a straight long wire AB carrying current I, and a charge Q is moving perpendicular to it with a velocity v. Here, as the particle moves perpendicular to AB, r, the distance between AB and Q varies, and hence the magnitude of the magnetic field changes, and thus, it is magnetic induction that plays here, and this is very different from the above case. Requesting viewers to come to your own conclusion regarding these. Thanks for watching.